Hi everyone, I'm Dr. Sayongji, teacher in charge of this project.
Today we are going to present our project named
Eggplant, Plant and Grow.
Hi, my name is Yap Singh, and today I'll be presenting to you my group's project, which is Eggplant, Crack and Grow. The problem statement of this project is the overusage of plastic in agriculture and the detrimental effects of plastic to the environment.
Introduction. Efforts to minimize plastic use in agriculture focus on reducing environmental pollution and promoting more sustainable, eco-friendly farming practices. Plastic mulch was first introduced in agriculture in the late 1950s and became widely used in the 1960s to improve crop production. However, long-term use has led to environmental problems such as soil pollution and microplastics accumulation.
Furthermore, through recent global warming effects, plastic particles are absorbed by plant roots and relocated to aerial sections of the plant. Seed germination, mineral composition, root and shoot growth are also negatively impacted on agricultural crops that result in lower crop yields and rise in applications of herbicides. According to Ladiner and Muley, invasive plant species may spread more efficiently due to soil modifications brought by plastic debris. Fragmentations of plastic particles during environmental weathering causes the appearance of nanoplastics. Due to the tiny size of plastic particles, it is possible that many organisms can ingest them quickly. Modern farming methods promote soil health, minimizing water use, and provide maximum output with minimum input with lower pollution.
Plastic pollution in agriculture shows that soil particles and plastic debris can be transported together into groundwater aquifers, and this movement depends on plastic properties, soil characteristics, and their interaction. Soil erosion acts as a major pathway for plastic debris to enter freshwater systems, while the size and shape of plastic fragments can also influence erosion processes. Plastic persists in soil, where they accumulate, break into microplastics and nanoplastics, and release additives. Microplastics and nanoplastics harm soil health and move within soil layer through leaching, microbioactivity, and farming practices. Therefore, plastic use and waste are expected to increase sharply, leading to more pollution in oceans and ecosystems by 2040. Low recycling rates and slow degradation are major causes of growing plastic pollution. Plastic pollution and waste significantly contribute to greenhouse gas emission and climate change, expected to worsen in the future. Plastic pollution threatens hundreds of marine and coastal species, as well as environmental changes and human health. In wheat plant was also studied. The experiment conducted by K. Sevki observed that exposure of microplastics and polypropylene negatively impacted the content of photosynthetic pigments in plants, as well as shoot and root growth of the plants and its photosynthetic capacity. The more the exposure to polypropylene and microplastics, plants show decline in chlorophyll, total chlorophyll, and carotenoid content of wheat leaves. Microplastics hinder photoelectron flow during photosynthesis and causes oxidative stress that can overwhelm antioxidant defense in wheat. Not only in wheat plant, both of the plastic particles achieve similar results in lettuce, maize, and rice, which are staples in our diet. Long-term exposure to polypropylene and microplastic may lead to increased toxicity ranking and growth reduction.
There are three objectives. Firstly, is to introduce a zero plastic method to grow plant. Secondly, is to verify the effectiveness of the method. And lastly, is to evaluate the environmental benefits of using biodegradable materials, such as eggshells in plant growth.
For the methodology, the materials needs are eggshell, soil, fertility organic-based potting mix grown with all-purpose wood soil, seeds, red beans, cherry tomatoes, chili, water, and container tray, egg holder. For the procedure, we need to crack a hole on the top of the eggshell. Pour the egg yolk into the container. Clean the eggshell. Place this under the sunlight and wait it to dry.
So the discussion of this project is firstly the uses of recycled eggshells as biodegradable planting containers, which is suitable for growing plants such as green bean, yellow beans, cherry tomatoes, chili, and limau. Secondly, it also includes the 5R concept, which is refuse, reduce, reuse, recycle, and rot. Thirdly, it also transforms kitchen waste into useful gardening materials, such as reducing the realizes of plastic seed trays, eggshells containing natural calcium, which enriches the soil and support healthier early plant growth. Fourth, it can investigate the dual function of eggshells, as it can act as a planting container, serves as a natural nutrient source. Fifth, it compares plant growth, which is the eggshell planting versus other planting methods. Sixth, it demonstrates a zero waste planting system, such as the eggshell can be transferred directly into a larger pot, no removal needed. This is because eggshells decomposes naturally, and it can continue supplying nutrients to the plants. And secondly, it promotes sustainable and efficient planting. And lastly, it minimizes environmental impact.
In conclusion, eggshells can be reused as biodegradable planting containers that support plant growth, such as beans, cherry tomatoes, chili, provide calcium for early development, and can be directly transferred into soil where they decompose naturally. The project supports the 5R concept by reducing waste, promoting reuse and recycling, and demonstrating an eco-friendly, zero-waste planting method that encourages sustainable resources use.
Moving on to the commercialization potential of this project. Firstly, eggshell-based planting pots present a viable, biodegradable alternative to conventional plastic seedlings container, particularly for nurseries and urban gardening applications. Secondly, the utilization of food waste as a primary raw material significantly reduces production costs while aligning with circular economy's principle. Finally, given the increasing global demand for sustainable products, these innovations offer strong potential for scalability supported by econ-conscious blending and market positioning. Next, I will discuss the contributions and impact of this project. Firstly, it addressed the issues of plastic overuse in agriculture by introducing a biodegradables and environmentally responsible alternative. Secondly, the incorporation of the XL contribute calcium carbonate, which support early-stage plant development and enhances soil quality. Last but not the least, the project operationalized the 5R framework, thereby promoting sustainable practice and increasing awareness of resource efficiency within the community. Finally, in terms of further study, firstly, a comparative analysis can be conducted to evaluate plant growth performance between XL-based containers and conventional alternatives such as plastic pot and its best system. Secondly, further investigation into the kinetic of calcium release of XL and its impact on different crop species will provide deeper scientific insight. Lastly, examining the biodegradable rate of XL under varying soil conditions will help optimize their practical application in diverse agricultural environment.